Next, we're going to talk about functions as equations. Function notation is another way of writing an equation of a function. Function notation would only be appropriate if we're talking about an equation who is already verified as a function. So function notation defines the range, or the y values, of the function by using any value in the domain, or x's. If an equation is a function, then we can substitute y with this new notation f parentheses x parentheses, which we don't actually pronounce it that way. We pronounce it f of x. So the f parentheses x parentheses is really pronounced f of x. So let's say I had an equation y equals 3x plus 1. In function notation, we would simply write f of x equals 3x plus 1. We just take the range, which is the y values, and replace it with this function in terms of x. Writing it in this form is actually a whole lot more descriptive. It tells you what value you're plugging in for x. So to find the value of a function at a given value or expression, that's value or expression, we substitute the value or expression into the equation and evaluate if it's a value, or simplify if it's an expression. So here's a function, f of x equals 2x minus 3. I want you to find f of 5. Now that's a value. So I'm plugging in 5 in place of x. So because I'm asking for f of 5, every time we see an x, we're going to simply put in 5. So we have 10 minus 3, which is 7. So f of 5 is equal to 7. Now in an ordered pair, we could describe that as the function value we put in was 5, was the input or domain. The function value that we output was 7, or the range. This would be an ordered pair notation, but function notation is f of 5 equals 7. Notice you plugged in a value, you get out a value. So I'm going to do this again, but this time I'm plugging in f of negative 1. So every time I see an x, I'm going to plug in a negative 1, and then I'm going to evaluate. Negative 2 minus 3 is negative 5. So f of negative 1 is equal to negative 5. Notice I plug in a value and I get out a value. On the next problem, it's asking me to find f of a. So I'm plugging in a variable, which means I'm going to get out an expression with more variables in it. So every time I see x, I'm going to substitute x in with a. So f of a is equal to 2a minus 3. Notice when you plug in a variable, you get out things with variables. Alright, next one. I'm trying to find f of a plus h. So every time I see an x, I'm going to take out the x and replace x with a plus h. So I have 2a plus 2h minus 3. There's no way to reduce that, so I am done. If I could simplify or reduce it, I would, but there's nothing that combines. So it's a matter of simply substituting whatever's in the parentheses in for x and reduce or evaluate. Now this next function is named g. G of x is the same as f of x. It's just like a name, okay? So just like my name's Miss Soleil and you guys all have your own names, g of x is just the name of the function. It's still in function notation even though we're using g instead of f. So in here I have a quadratic function. So every time I see x, I'm going to take x out and replace it with -2. So I have -2 squared plus 3 times -2 plus 5. Evaluate that. I'm getting 4 minus 6 plus 5, -2 plus 5, or +3. So g of -2 is equal to 3. The input is -2, the output is 3. I plug in a value, I get out a value. I'm going to try g of 1 now. So I have x squared plus 3x plus 5, getting it from this function up here. But instead of x, I'm going to plug in 1. So 1 squared is 1 plus 3 plus 5, which is 4 plus 5, 9. So g of 1 is equal to 9. I plug in a value, I get out a value. On the next one, I have g of a. Again, my g of function is x squared plus 3x plus 5. But instead of x, I put a parentheses, and then I just substitute the a into every single parentheses. So that leaves me with a squared plus 3a plus 5. So therefore, g of a is equal to a squared plus 3a plus 5. Notice that I really can't do much with that. There's no simplifying to be done there. Okay, on our last problem, we have g of a plus h. So every time I see an x, I'm going to put an open parentheses and come back and fill them in with a plus h. Now this problem is a little bit more difficult because when you have a binomial squared, you have to write it out twice. I can distribute the 3. But here I have to go ahead and distribute some more. I cannot square in my head unless you've memorized the formula. So I have a squared plus ah plus ah plus h squared. These two add up and I get a squared plus 2ah plus h squared plus 3a plus 3h minus 5. Oh my goodness, that's very long. There's nothing else I can combine here, so I'm just going to go ahead and write this out here to the side. G of a plus h is equal to all of that lovely stuff. If I plug in things with a's and h's, I get out things with a's and h's. When I plug in values, I get out things with just values. When I plug in a number, I get out a number. Next, we're going to perform combinations of functions. So if I have f plus g of x, all I'm going to do there is take f of x, then plus g of x. Very simple. If I have f minus g of x, I'm going to take f of x minus g of x. If it says f times g of x, you just take the first function times the second function. And then this division is f divided by g of x is just simply f of x divided by g of x, where g of x can't be equal to 0. So why do we have that weird restriction only on this one? Well, because g is in the denominator, and we know we can't ever divide by 0. We know that that's a rule, and we're not allowed to ever divide by 0. And g of x is a function, a varying function. It could be possibly any number of values. G of x could possibly be 0, so we put this little restriction here just to make sure everyone knows, hey, if g of x is 0, then this doesn't actually work. It's just something that we must put in order to write the definition. So basically this is just a different notation. If it says plus within the function, well then you just take the two functions and add them. If it says minus, you just subtract. If it says multiply, then you just multiply, and if it says divide, well then you just take the two functions and divide. Let's practice these. So I have two functions here at the top. We'll do all of the f functions in red and all of the g functions in blue, and then we will combine like terms. So on this problem it says f plus g of x. Well, we know by the definition we're just going to take f plus g of x. So I'm just going to take the f function, which is 3x squared plus x plus 4. I'm going to add it, because that's what the problem said to do, add it to the blue function, or g of x, which is x minus 1. At this point, all I have to do is combine like terms. So I have 3x squared, he has no partners, okay? X plus another x, that should get me 2x. And then 4 minus 1, that's positive 3. So f plus g of x is equal to a new function, 3x squared plus 2x plus 3. If I take one function and I add another function to it, I get a brand new function. The next one is also pretty simple. We have f of x minus g of x, minus because that's what they told me to do in the problem. So my red function, that's pretty simple. The f of x is 3x squared plus x plus 4. Now minus is a little bit more difficult than plus because I am not only subtracting the first term of g, I'm subtracting the entire g function. So because I'm subtracting the entire g function, you need to remember to put parentheses around the g function, and then we're going to distribute through to get minus x. Everybody gets minus x, right? It's the plus 1 that they sometimes will want to write minus 1. But when we're subtracting a negative 1, that's really like adding a positive 1. So I have 3x squared plus x plus 4 after I've distributed minus x plus 1. And then I'm just going to combine like terms. We have 3x squared. Then I have plus x minus x. Well, that adds to 0. And then lastly I have plus 4 plus 1. That's plus 5. So f minus g of x is equal to a new function, 3x squared plus 5. Okay, on this next one I have f times g of x, which just means I'm taking f of x times my g of x function. My f of x function is 3x squared plus x plus 4, and my g of x function is x minus 1, and I am multiplying. So because I can multiply polynomials, I know how to do that. I'm just going to go ahead and distribute here. So 3x squared times x is 3x cubed. 3x times negative 1 is 3x. Plus x squared, that's 3x squared. Plus x squared minus x plus 4x minus 4. So I have 3x cubed. When I combine these two, I get minus 2x squared. When I add those two, I get 3x minus 4. So f times g of x is equal to, again, a new function, 3x cubed minus 2x squared plus 3x minus 4. My last example, I have f divided by g of x, so I have f of x divided by g of x. And we're going to assume that g of x can't be 0, okay? Because that's part of my function. So my red function is 3x squared plus x plus 4 divided by g of x, which is x minus 1. Well, there's not really much I can do here. This is actually completely solved for f divided by g of x, but I haven't yet taken care of this little item up here. We know that this is only true where the denominator, g of x, is not equal to 0. So if I set x minus 1, the denominator, the g of x, not equal to 0, and then solve it, I know that this is only true where x cannot be equal to 1. So although this is the answer, you also have to put a disclaimer on the side that says where x can't be equal to 1. This has to be along with my answer. And that concludes this lesson on functions.